What if I told you that you could kill your grandfather and still exist? Sounds impossible, doesn't it? Welcome to the mind-boggling world of time paradoxes. Picture this, folks. You've somehow managed to harness the power of time travel. You decide to take a trip to the past, maybe to see a dinosaur, or to witness the creation of the pyramids. But in a twist of fate, you accidentally end up offing your own grandfather. Now, according to the laws of causality, you should cease to exist, right? Because if your grandfather is no more before he could meet your grandmother, then your parents wouldn't be born, and neither would you. But here's the paradox. If you don't exist, then who went back in time to kill your grandfather? This is the classic grandfather paradox, a thought experiment that's been making scientists scratch their heads for decades. It's a prime example of a time paradox, a situation where the use of time travel would result in a sequence of events that contradicts itself. It's like trying to square a circle or fit a round peg into a square hole. It just doesn't add up. But what if the reality of time travel is not as straightforward as we think? What if, when we meddle with the past, we're not actually changing our own timeline, but creating a new, alternate timeline? This is known as the many worlds interpretation of quantum physics, and it's just one of many theories that try to explain how time paradoxes might work. Another theory suggests that the universe has a way of correcting itself when paradoxes occur. It's called the Novikov self-consistency principle, and it posits that if you went back in time with the intention of killing your grandfather, something would inevitably prevent you from doing so. So, if you could travel back in time and prevent your grandfather from meeting your grandmother, would you cease to exist? A head-scratcher, isn't it? Now imagine this. A butterfly flaps its wings in Brazil, causing a tornado in Texas. Sounds absurd, right? But in the grand scheme of things, it's not as far-fetched as you might think. This is known as the butterfly effect, a concept originating from chaos theory. The butterfly effect suggests that a small change in one state of a deterministic nonlinear system can result in large differences in a later state. This concept is directly linked to time paradoxes. But what does this all mean? Let's break it down. Imagine our universe as a gigantic, intricate machine. Every cog, every gear in this machine, no matter how minute, plays a pivotal role in the smooth running of the whole system. In this context, the butterfly's tiny wings are akin to a minute cog. A single, seemingly insignificant flap can set off a chain of events leading to a major outcome, like a tornado miles away. This is a deterministic, non-linear system in action. Deterministic means the future state of the system is determined by its current state, following a set of rules or equations. Non-linear signifies that these rules aren't straightforward. They can involve squares, cubes, and other higher powers of the variables, making the system highly sensitive to initial conditions. So, how does this tie into time paradoxes? Well, if you were to travel back in time and cause a minute change, say prevent that butterfly in Brazil from flapping its wings, you could potentially return to a drastically different future. This is because the system of our universe, being non-linear, would have evolved differently due to the changed initial condition. The tornado in Texas might not have occurred, altering the course of events that followed. This is a direct manifestation of a time paradox, where an action in the past changes the future in unforeseen ways. So, even the tiniest changes in the past could dramatically alter the future, creating a time paradox. What if you could travel back in time? Would you change your past? And if you did, how would it affect your present? Let's dive into the time traveler's paradox, a fascinating concept that has been a source of both intrigue and bewilderment for scientists and science fiction enthusiasts alike. It's a theoretical situation that explores the consequences of meddling with time. Picture this. You've managed to invent a time machine. Thrilled with your success, you decide to travel back to a moment in your past. Maybe it's to relive a joyous event, or perhaps to rectify a regret. You alter your past, and then you return to your present. But here's where things get tricky. By changing your past, have you not also changed the sequence of events that led to you inventing the time machine? If your past is altered to the degree that you never invent the time machine, then how did you travel back in time to change the past in the first place? This is the crux of the time traveler's paradox. It's a conundrum that toys with the very fabric of our understanding of time and causality. Some argue that this paradox proves that time travel is impossible, as it would violate the fundamental principle of cause and effect. Others propose the existence of multiple timelines or parallel universes to circumvent this paradox. In these theories, each alteration of the past creates a new timeline or universe, leaving the original one untouched. But these are just theories, and the truth remains elusive. The time traveler's paradox is a thought experiment designed to challenge our perceptions of time, causality, and the universe itself. It's a reminder that the universe we live in is filled with mysteries and paradoxes that we are yet to fully comprehend. If you could alter your past, would you still become the person who wanted to change it? This question lingers, encapsulating the essence of the time traveler's paradox and leaving us with much to ponder upon. Time paradoxes are not just fascinating, they are terrifying. Why? Because they challenge our understanding of the universe. When we delve into the realm of time paradoxes, we're not just opening a Pandora's box of bewitching mysteries, we're also challenging the very fabric of our understanding of the universe. It's not just about the thrill of hypothetical time travel or the allure of changing the past. These paradoxes can potentially disrupt the fundamental laws of physics, effectively shaking the deterministic nature of the universe. The deterministic universe, as we understand it, follows a set of laws: cause and effect, action and reaction. But time paradoxes, they laugh in the face of these laws. They imply a universe where the effect can precede the cause, where the future can influence the past. It's like trying to comprehend a game where the last move determines the first. It's a mind-bending concept that challenges the linearity of time and our perception of reality. Now, imagine a universe where time paradoxes are not just theoretical but practical, where they happen as naturally as the rising and setting of the sun. The implications are staggering. It could mean a universe where the space-time continuum is in a constant state of flux, ever-changing, ever-evolving. It could potentially open up a world of infinite possibilities, where we can rewrite history at will, where the future is not just unknown but unknowable. But there's a darker side to it. What if we alter something in the past that results in our own non-existence in the future? What if these paradoxes lead to a ripple effect, creating more and more paradoxes, ultimately leading to a cascading collapse of the space-time continuum? It's a chilling thought, the destruction of the universe as we know it. So, time paradoxes could either open up a world of infinite possibilities or lead to the destruction of the universe as we know it. In the realm of time paradoxes, every action has an unpredictable reaction, every cause an unimaginable effect. As we journeyed through the intricacies of time paradoxes, we've explored some of the most perplexing concepts that have left scientists scratching their heads. From the enigma of time paradoxes to the uncanny implications they present, we've delved into the depths of the unknown. Let's take a moment to revisit these compelling phenomena. We began our journey with the grandfather paradox, a concept that challenges the very fabric of our understanding of time. It's an idea that grapples with the possibility of altering the past in such a way that the future as we know it would cease to exist. A perplexing notion, isn't it? Next, we ventured into the realm of the butterfly effect, a phenomenon that suggests that even the flutter of a butterfly's wings can cause a typhoon halfway around the world. It's a concept that emphasizes the interconnectedness of all things and the vast unpredictability of cause and effect in our universe. Then we delved into the time traveler's paradox, a concept that further complicates our understanding of time and space. It toys with the idea of a person traveling back in time and the potential implications of their actions on the present and future. These concepts, while fascinating, also present a terrifying reality. The implications of time paradoxes are far-reaching and unpredictable. They challenge our understanding of reality and force us to question the very nature of time itself. So, as we conclude this journey, let's remember that the world of time paradoxes is a realm where nothing is as it seems. It's a world that defies our understanding and challenges our perception of reality. Remember, in the world of time paradoxes, nothing is as it seems.